Here in this video, we are talking about a specific property of a material that belongs to heat, that is specific heat. So what is that specific heat is defined as? Let me have a look at that first of all. It is defined as amount of heat energy required. Why do we need a heat? To raise the temperature of a body. Whenever you want to raise the temperature of a body, we shall supply the heat. How much of the heat that you supply? For 1 degree centigrade. But be careful, you are raising the temperature only for 1 degree centigrade. Amount of heat energy required to raise the temperature of the body by 1 degree centigrade per unit mass of that substance. You are not going to raise the temperature of the entire body but of only unit mass. Is called specific heat. So specific heat is defined as amount of, shown with an S, heat energy required to raise the temperature of unit mass of substance. That's why mass came into the denominator. For 1 degree centigrade rise in temperature, that's why temperature also came into the denominator. Whoever say unit, they will come to the denominator in any mathematical equation. From this, if I have to write a SI unit for this, dq is heat. It is measured with a unit of joule. Mass is in kilograms. dt is the temperature. Be careful, that's temperature in degree centigrade or degree Kelvin, both are same, right? So the unit of this is joule, kilogram power -1, Kelvin power -1 or degree centigrade power -1 in SI system. If I want to write a dimensional formula, if I have to write dimensional formula for this specific heat, heat is an energy. So dimensional formula of energy is ml square T power -2 by mass by temperature. I am showing with K like a Kelvin. So this m and m can be cancelled. So m power 0 L square T power -2 K power -1 is the dimensional formula of water of specific heat. Say for example, specific heat of water is a standard value, depends on the nature of the water or nothing else. 1 calorie per gram per Kelvin. See, the unit looks like different. Let me explain what's the meaning of that is. Specific heat of water is equal to 1 calorie per gram per Kelvin. What's the meaning of that? To raise the temperature of 1 gram of water here by 1 degree centigrade or 1 degree Kelvin, both are same. To raise the temperature of 1 gram of water by 1 Kelvin, we need the amount of the heat required, that is equal to 1 calorie. So to raise 1 gram of water's temperature by 1 degree centigrade, amount of heat required for you is 1 calorie. Suppose you want to say this in SI system. We know 1 calorie is 4.2 joule. 1 gram is 10 power -3 kilogram. Kelvin is same. So 1, 4.2, 10 power -3 becomes 10 power +3 joule, kilogram power -1, Kelvin power -1. So that is 4200 joule, kilogram power -1, Kelvin power -1. So specific heat of water can be expressed either in this system with calories or in SI system with the joule, kilogram and Kelvin. So specific heat is amount of heat required to raise the temperature of unit mass of substance by 1 degree centigrade or 1 degree Kelvin. Now, as I told you, it depends on the nature of the material. To extend that further, to raise the temperature of unit mass of substance, That's why I have written 1 by m. Suppose you want to raise the temperature of total mass of substance. To raise temperature of total mass of substance, of any substance, by 1 degree Kelvin is, as I want total mass, I have to take this mass to other side. dq by dt becomes, take the mass to the other side, mass into specific heat. This dq by dt is called heat capacity. So I can define heat capacity now. That is the amount of heat required to raise the temperature of total mass of substance by 1 degree centigrade. I want you to observe carefully. Here in specific heat to raise the temperature of the unit mass of substance by 1 degree. Here in latent heat to raise the temperature of total mass of substance by 1 degree. That's the only difference. So if I have to write the unit of this is called heat capacity. Heat capacity. dq is measured in joule by Kelvin. So its SI unit will be joule per Kelvin. So how specific heat and this heat capacity are different? Heat capacity is also called as thermal capacity. How they are different is, in the case of specific heat, you raise the temperature of unit mass of substance, whereas in heat capacity, you raise the temperature of only total mass of substance, not the unit mass of substance. That's how it is different. So, how these two are related to each other, specific heat and heat capacity, how they are related to each other, it's very simple. Specific heat is 1 by m into dq by dt. 1 by m into dq by dt can be written like thermal capacity. It implies, you can say, thermal capacity or specific capacity is equal to, take the mass to the other side, mass of the material multiplied by its specific heat. So it is obvious that thermal capacity depends on mass of the material, mass of that particular material. Of course, also depends on nature of the material, that how much heat it takes. Whereas specific heat, it is not going to dependent of mass because there is no term there, not dependent of mass. That's the difference between specific heat and the heat capacity. Now let's talk about another term called something like a water equivalent. Yeah, there is one more term called water equivalent. Previously, this is the first heat is a kind of a science that we know right from many days. First kind of a science. People know about heat for many years and right from many generations. And at that time, when they know about heat, what is there? Everything around is water, and people try to measure or prefer to measure things in terms of water. So, what is water equivalent? Is simply, you say, for example, with thermal capacity of a body. What do you mean by thermal capacity of a body? To raise the temperature of total mass of that body by 1 degree centigrade, we need some heat. So with thermal capacities of a body, we need to supply some heat. Why do we supply that heat? To raise the total mass of substance by 1 degree centigrade. With that heat, with the thermal capacities heat, we can raise certain mass of water's temperature by 1 degree centigrade. That certain mass of water whose temperature can be raised by 1 degree centigrade using a heat equivalent to thermal capacity is called water equivalent. So water equivalent is simply certain amount of water whose certain mass of water whose temperature can be raised by 1 degree centigrade using a heat equivalent to thermal capacity of that body. So that's the water equivalent of that thermal capacity of that body. It comes to that particular body. So it is measured in grams. Actually, water equivalent and thermal capacity both are same. They are representations of two different things in two different terms. Thermal capacity is in terms of heat. Water equivalent is represented in terms of water. Both are same in nature, but water equivalent is measured in grams, whereas thermal capacity is measured in joule per Kelvin. So maybe just for the record, let me define water equivalent once again. That's the amount of mass whose temperature can be raised by 1 degree centigrade using a heat equivalent to thermal capacity of that body. It is measured in grams. But the magnitude of thermal capacity equal to magnitude of water equivalent. The numerical values can be taken identically whenever a problem occurs. That's how we need to solve the problem. Thank you for watching.